Hello, fellow problem solvers. So today we're going to be doing another lead code problem, this time the palindrome number. So it asks, given an integer x, return true if x is a palindrome integer. Okay, so what is my thinking here? Well, what do we need? We need x0 to be equal to x negative 1, like the first and the last need to be equal. Then we need x of 1 to be equal to x of negative 2, like the second to last, and so on and so forth. And if only all of these things are true, then we need to return true, otherwise we're returning false. So one way of going about this is to think about this, recursively. And then we can return, so we can return what we need. x0 equals to x negative 1, and is palindrome of what we need is palindrome of x starting from 0 and ending at negative 1. I believe this is the case. Let's test this out. Actually, before we test it out, we need to have, if length of x is equal to 1, then we need to return true. Actually, either 1 or 0. Could it be 0 at any? Yeah, or length of x is equal to 0. What I'm thinking of is, say you have two of them, then this might give like the empty set. And oh, but x is an integer, it's not a string, so we cannot really do this. Now I just realized that. Well, then we need to translate this base 10. So how do we do that? I invite you to pause for 2 to 5 minutes and figure that out. So the quickest way of actually doing this is if you say scroll down. Here it says a follow-up. Could you solve it up without converting the integer to a string? So it tells us, the simplest thing for us to do here is to say let x be equal to the string representation of x. And then we run all of this. So let's see what happens when we do that. Like then this is a string, and then we can do all of these length checks. I believe we can do the length check on a string. Let's see what happens when you run the code. And running the code, we have a runtime error. This palindrome is not defined. Oh, it's in the class solution. So self dot is palindrome. And now when we run this, we have true. Beautiful. Let's put in our own test case, 1, 2, 1, 2, 1, 2. This should not give us anything different. And the other case I want to check out is if there's an even number of digits, just to make sure that this is running correctly. True, true. And what happens if this is free? Then this should all be good, and we're good to go, I think. Yes, it's false. What if there's a negative number? And we run the code and we see again, now let's see, false, the expected output is false. And with that, we are done. We can now submit this. And what happens when we submit? Let's see it. And we get it's a success. Beautiful. So now, okay, faster than this. We don't have much memory usage, which is nice. This thing isn't so cool. Now the question is, could we do this without converting x into a string? And here I think this would be an interesting problem to think about. I invite us to pause for another 2 to 5 minutes and figure that out. So if you think about this as an integer, what is x? We're looking at representation of x is, say, some number, it's an, if these are the digits, an minus 1, and all the way till, say, a1 and a0. This is like the decimal representation of x. And now, how can we compare a0 and an? Well, instead of this, what we would be really comparing is we'd be comparing, say, x divided by 10 to the power of n, and this being an integer. We'd be curious if this is equal to x. How do we get the first digit? Well, we get it by saying x mod 10, right? That's how we get a0, and this is how we get an. Like this is really like mod 10. Actually, is it though? Is it mod? No, it's not mod 10, but it's something, you know, similar in that similar character, because once you divide x by this, actually at 10 to the nth, or maybe x to the 10 to the power of n minus 1, once you divide by this, what will happen is, so when you divide by 10 to the first, you get this. Oh yes, so it's 10 to the n. Given how we made this, you will get something like this number. And then an is going to be the integer part, and this is going to be the fractional part. So here, instead of, so here what we can say is if, I'm still curious about our base case, but here what we need to figure out is what x is modulo, like what is its highest power k that divides it. And for this, I think it's first good for us to like figure out like what is the highest power of 10. Actually, like what it, like how many digits does x have? And to do that, I think, let's say it has, if it has one digit, that's x to the I. So now let's see, while x divided by 10 to the power of 10 to the power of I, while this thing is it strictly greater than 1? Yes, I'm thinking while it is actually, while this is greater than or equal to 1, we need to add 1 to I. And after some point, this will no longer be the case. So if it has 2 digits, what will we get? We will get, say if we have 10. Let's look at that out. Say if we have 10. Then at the beginning, we would get, no, this is not true. Then we would get x would be 10 over 10. It would be 1 greater than or equal to 1. Okay, so now we want to actually strict equality. So now we get 1. We want to break, and what we get is that I will be equal to, actually, wait a second, greater than or equal, yes, greater than strictly. If it's, actually, no, let's wait a second. I invite you to take 2 to 5 minutes and figure out if it's greater than or equal to and finish this problem. So it's greater than or equal to, and now what this gives us, now I is the number of digits. And now that we know the number of digits, we can just like not calculate it again and again and again and again. We can just say def help palindrome help pal self x, which is of type integer, and we can also have, well, what we call this, say n, which is also of type integer, which tells us how many digits there are, and we give out a bool. And this will be like the thing that will return a thing at the end. And now we will call self.helpPal. What do we need? We need, so we have x and I, and we will actually return this. And here we will do the heavy lifting. Here we'll say this thing right here, x. We need to have x divided by 10 to the power of n, power of I. Actually, to the power of I, it has to the power of I minus 1. I is the number of digits, I here to the power of n minus 1, because n is the number of digits it has. We need to check that this is equal to x modulo 10. So this is our return this. And at the same time, how do we get the rest of the digits? Like how do we clear an and just get the rest of this? So one thing I am thinking about is to, how do I call this number? Like, what is the simplest way to get it? Well, one is to subtract a, well, we can subtract a0, and then we'll get an all the way till a1 and 0. And now we can then divide by 0, and then we'll have an all the way till a1. Now we also want to get rid of this thing right here, an, and the way we do that is by, what is this? This is, we want to say minus an to the power of 10 to the n minus 1 here, or in this case n minus 2. So let's actually call this number a this number here is A needs to be that, and what is the new number that is going to be the new X? Let's call this number M is going to be what? So it's first going to be X minus, actually we don't need, we can just do this, X divided by 10. This gives us a 1, like this is the same as minus X mod 10. And then we need, after we have that, we need to subtract from this number A to the power of A times, that's going to be, I think it's A times 10 to the power of what? N minus 2. So let's see if this is actually good. And then what we're going to return is A is equal to X. And we're going to call the self.helpPal on what? What are we going to call it on? We're going to call it on M and N minus 2. But before that, we also need a base case. And that is literally if, okay, so this is if N is equal to 0 or N is equal to 1, then we return true. Otherwise, we are doing this. And now let's see what happens when we run our code. What happens here is we get, let's see, output true, but actually is false. Oh yes, we also need to double check. We need to check that this is actually, if X is less than 0, return false. And then we do all this good jazz. And let's see, okay, now this returned false as we needed it to. But when we do something like this, please try again in a couple of seconds. Okay, is it too soon now? And we get, it's a false. When we run 22, do we get it to true? And we get it to true. 212, do we get it to true? Let's see. And oh, there's one more question. What if I have zeros here? What will happen then? This is also a case that we need to look at because we're no longer looking at these as digits, but rather as numbers, because what we will get is we will be calling the number, calling it on this number, and I is equal to 3, and we need to handle that somehow, right? Actually, yeah, this is an invalid test case. But yeah, I think this doesn't work. So now I invite you to take another 2 to 5 minutes and try to figure this one out. And for me, what I've figured out, like once I've ran a couple of these and done some print statements, is that this actually seems to be working. It saves itself somehow. I think this thing actually makes, either it makes A equal to 0 and it doesn't change X. Yeah, I think that's what happens. It makes A equal to 0 and then X doesn't change. And X and M are going to be like, it's going to be X over 10. So this actually looks pretty cool if it works. Let's see now what actually happens when we submit this. And it happens then faster than 10% of, so it's worse. We have more memory usage. But hey, it's a way to do it without utilizing the fact that X is a string. And I hope you enjoyed this problem. And as always, thanks for problem solving.